All right. Hey, so we're looking at the question here. This is a solid of revolution here. So we're going to rotate a region bounded by this graph and this graph, and the x equals 1 and the x equals 5. So here's a rough, very rough sketch of this graph. Here's the x equals 1 line. Here's x equals 5 line. And we're going to rotate it around 8 way up here. So y equals 8. All right. And each of these, so each of these are a parabola. One's a parabola that's just right in this area. That's the green parabola, which is listed here. And then here's the red. I'm calling this kind of like the red parabola. So this is sort of like the outer portion of this sort of ring. It looks like we're kind of doing like a ring with sort of like a curved outside and a curved inside as well. Okay. So the way I thought of this is, well, let's take the red volume, all right, and we'll take away the green volume, right? So I'm going to take this whole red thing, which would encompass basically from 8 all the way down to this parabola, and then we'll rotate that around and create a volume. Then I'm going to remove the green volume from that, which would be this inner section right in here. So how do we figure out this red volume? Well, it's pi r squared, and r is the radius, this red radius here, and I've labeled it over here. And it's basically the difference between 8 and this graph, this parabola down here, okay? And so we end up getting 8 minus this, all right? It's the difference between these two lines, this line and this line. This line here happens to be a curved line, right? And so we could figure out all sorts of different distances, radii, in this area. All right, so now, how do we find the green volume? Well, it's, the same idea. It's the distance between 8 and this parabola here. Okay, so it's 8 minus that parabola. So it's the difference between those two things. So remember, in order to figure out, it's easier to visualize in the green one. In order to figure out this distance right here, we would go to 8, and then we would take away this, and you would be left over with this. Or if I'm talking about this middle portion, you would go to 8, and you would take away this little bit right here, and you would be left with this radius here. Notice the radius is getting bigger, and then it starts to get smaller here. But that's what that happens because you've left all these x's in here. And now basically this is what we're looking at, right? So here now in the next step, what did I do here? I took the 10 and the 8, combined them, the 10 and the 8, combined them. Don't forget that these guys are squared. Oh, it looks like I factored out a pi. Notice they're both from 1 to 5, which is this distance here. So I've gone ahead and I've written them as a single integral from 1 to 5, factored out my pi. Then this portion right here, I went ahead and just squared these trinomials and simplified it. Made, I don't know, 1,000 mistakes, but finally got it right, I think, down here. And then I just integrated from 1 to 5. And so here's my 5. Oh, so no, here I actually integrated it here. So 320x, 192x is 96x squared, 32x squared is 32 over 3x to the third. Now I'm evaluating the integral from 1 to 5. And so there it is. I've evaluated it at 5, evaluated it at 1. And so apparently here is our volume, 196 pi over 3. A lot of opportunity to make mistakes, for example, in this step right here from getting here to here. And also a lot of opportunity to make some mistakes when you're squaring these trinomials and starting to figure all this stuff out. Now, one way of looking at this is to keep these as separate intervals and do u substitutions on each of these intervals separately. That might be actually a better way of looking at this, and you don't have to square these trinomials and combine them as the same integral. Okay, so lots of different options for this one. Okay, all right.